Hi. Today I'm going to talk about the Ocsigen project. Ocsigen is a project that I've been working on for over 15 years with Jérôme Vouillon, and on which dozens of people have worked over the years and are still working. The aim of the Ocsigen project is to provide OCaml with a comprehensive set of tools and libraries to make websites, but also web application and even mobile application for Android and iOS. And we wanted these tools to be state-of-the-art in the field and even better if possible. Ocsigen started out as a research project of the CNRS and University Paris Diderot, then INRIA. We spent years trying to simplify application programming and make it safer and more reliable. We did this with the goal of providing an industrial strength framework, which is now used in production. More concretely, Ocsigen is a set of open source projects that are, as far as possible, independent from each other, so that you can use only what interests you. I've listed here the main project. We have about 15 projects and hundreds of thousands of lines of codes. Historically, the first Ocsigen project is LWT. LWT was initially written by Jérôme for the Unison file synchronizer, and we decided to use it for Ocsigen, make it a separate package, and distribute it separately. We also have the JS of OCaml compiler that you probably already know, the TY XML library, which allows you to make typed HTML. Ocsigen server is a modular web server, and the core of the framework is Eliom. Eliom is responsible, for example, for the server-side page generation and sessions, but also client-side page generation and communication between server and client. Eliom turns OCaml into what we call a multi-tier language, which means that you can write a distributed web application fully in OCaml as a single program. And then we have a widget library, Ocsigen Toolkit, and Ocsigen Start, which is a high-level library with features such as user management, for example. As I was saying, Ocsigen has been implemented by many people. I've put a list here. I hope I haven't forgotten anyone. If I forgot your name, please tell me. I would like to cite the names of the leading developers who have contributed significantly to Eliom, particularly on other projects, and especially Pierre Chambard, Grégoire Henry, Bénédicte Becker, Vassilis Papavassiliou, Hugo Ozar, Gabriel Radan, etc. If you belong to the OCaml community, there are probably many names you recognize in that list. I'm going to try to give you a wide overview of all the features in a single slide very quickly now, and then we'll go into a bit more detail. Eliom is a web framework that can be used in the same way as any other web framework to generate server-side web pages, and in a very standard way. We obviously have HTTP management. We are now using the co-HTTP library for that. We decided to switch to co-HTTP a few years ago. We had our own implementation of the HTTP protocol that worked very well. The switch to co-HTTP has been decided with the aim of integrating ourselves into the OCaml ecosystem as much as possible. So like all web framework, we have the ability to generate HTML pages, to write templates, to send pages as streams. We have a routing mechanism. You can, of course, handle get and post parameters, form, cookie, session, write REST API if you want. and send data through JSON. That was basically Ocsigen 15 years ago. But I told you earlier that you can develop in a completely traditional way with Ocsigen. But in fact, you will see that we can also do much better than that. And as a research project, we've tried to find better solutions. And the first thing you probably think about when you are an OCaml developer and you want to improve things is type checking. We introduce type checking almost everywhere. For example, we introduced type checking of HTML thanks to the TY XML library. We also check the types of get and post parameters. We have type checking of links, forms, session data, etc. Eliom is also proposing a very advanced service mechanism which with rich routing possibilities, and it implements what is called continuation-based web programming and many other features like action services, scope services, and automatic URL generation. Eliom has a very powerful session mechanism with scopes, very simple to use, and it provides protection against many security flaws. Ocsigen I18N is an internationalization library for OCaml programs. So, right from the start, we had the idea that we needed to go further than just simple server-side page generation. We wanted to write applications. And for that, we needed a way to run programs in a browser. That's why we implemented JS of OCaml. JS of OCaml lets you run OCaml programs in the browser, translating them into JavaScript. This allows you to make what we call single-page applications. But again, we thought we could do much better than that. Now we can use the same language on both sides. Why have to choose between making a website or a single-page app? Why not invent a model that would unify the two? For example, when you generate server-side pages and add and then-click on an element, you want to write the event handler in OCaml. And if you have some code that runs client-side, why not be able to call a server-side function directly just by making a simple function call? So Eliom lets you write websites, but it also lets you write applications distributed between a server and a browser, completely in OCaml, and with a single code. That's what we call multi-tier programming. This is implemented by adding annotation to your OCaml program to specify on which side you want the code to be executed. From that, we extract two programs that are type checked together, and communication between client and server becomes straightforward because, for example, you can inject server-side values in client-side pages, or you can call server-side function from the client. You don't need to generate your API manually. Eliom does that for you if you want. Pages can be generated either from the server or the client, depending on the situation. And the great thing is that you retain compatibility with the traditional web programming style, links, URLs, forms, bookmarks, sessions, etc. And when you follow a link, the client-side program does not stop. We also have server-to-client communication. We have reactive programming, either in the browser or even client-server reactive programming. JS/OCaml provides a very elegant way to handle browser events using LWT. And of course, we have higher level libraries. JS/OCaml makes it very easy to write bindings for your favorite JavaScript library. We also developed our own widget library, Ocsigen Toolkit, which is designed explicitly for this client-server programming model, but which you can also use for client-side application as well, of course. We also have Ocsigen Start, which provides higher level library, like, for example, user management. But that's not all. Now that we know how to generate pages on the client, now that we know how to make programs that communicate with the server, why not implement mobile application for iOS and Android? And our mobile application use exactly the same code as the web application. They are compiled into JavaScript and use a web view for display and tools like Capacitor or Cordova to access all the phone's features. Contrary to popular belief, this web-based programming method for mobile application is perfectly acceptable and presents no performance problems for most applications, provided it is done correctly. So this was a wide overview of most features of all our projects. As you can see, Ocsigen is very feature-rich. The project is mature, actively maintained, and used in production, for example, for the Bisport social network. Before speaking more about Bisport, I'd like to mention the main novelty in the world of the web in OCaml, which is the arrival of WASM of OCaml. Thanks to Tarides and Jens Fritz, Jerome has been able to develop a compiler on the model of JS/OCaml, which compiles OCaml to WebAssembly, which means that all of this is already working in WebAssembly. In particular, we've run the Bisport code with WASM of OCaml, and it works. I'm now going to give you a demonstration of Bisport. Bisport is a social network for sports and athletes with features like very similar to Facebook. You have user pages. You can ask users to become your friends. This is, for example, my Bisport page with all my publication, my pictures, my agenda. You can follow users. You have and you have a feed that aggregates the content of all the pages you follow. You also have group pages and event pages. This is an example of group page. Sport has lots of features to help sport clubs manage their activities. For example, you can create a training session, invite members, broadcast matches or match summaries, and communicate with fans. There is also a collaborative scoring tool, for example. So this is an example of an event page. The difference with Facebook is that groups and events are three structures, reflect the structure of sporting events and associations. For example, you have federation, clubs, teams, or competitions that contain matches. Bsport also has a personalized news feed according to your tastes. Bsport aims to become the global social network for sport. For the moment, Bsport includes 98% of sport clubs in France and all their events at both professional and amateur levels. I've shown the web version of Bsport, but Bsport is also a mobile application for Android and iOS, all written as multi-tier OCaml programs with Eliom, NGS of OCaml, Ocsigen Star, Ocsigen Toolkit, etc. To implement Bsport, they needed a way of quickly introducing features that would compete with other social networks. Facebook was born in 2005 and has had years to improve its application. But when it came to implementing Bsport, it was impossible to start with the 2005 version of Facebook because big American companies are accustomed people to a level of quality that they absolutely had to achieve very quickly. So they were faced with a dilemma. How could they, with limited resources, implement a social network that would resemble Facebook in terms of functionality, ease of use, user experience, and ergonomics? And to meet this challenge, the solution they chose was Ocsigen, because multi-tier programming, type checking, multi-platform programming, etc., can drastically reduce the development time. I decided to join together with Jérôme 8 years ago, and it's a wonderful experience. So what does it look like to implement a social network in OCaml? Let's go to the technical part of this talk. I will try to convince you that it's not very difficult to use because everything remains very similar to what you would do with other frameworks. It's very similar to server-side page generation with some improvements. First, server-side programming. I will show you how to do web development with Eliom and how to develop a website in OCaml. And we will see web application in the next part. Pages are generated by services. In that example, I'm defining a service called my service. And to do that, I'm using a function called Eliom service create, which takes 3 parameters. The first one is the path on which you want your service to run, to be available. This one will run on path/who. The second argument describes the HTTP method to use and the parameter your page is taking. Here, I will use the get HTTP method, and any means that it can take any get parameter in the URL. Then I register on the service the function that will generate the page. In that example, I'm using the TYXML library to create HTML. You can see how it works. For each of the HTML tags, we have a function. For example, function HTML takes 2 parameters, head and body. function body takes as parameters the list of the elements you want in the body, etc., etc. It is also possible to use the templating syntax like this if you prefer the usual HTML syntax. In this example, the service returns HTML, but you can choose what kind of data you want the service to send by choosing the appropriate registration module. There are many predefined registration modules, one for sending type HTML, one for sending files, one for CSS, one for doing redirection, one for performing actions. Actions are services which perform a side effect on the server and possibly redisplay the current page afterwards. And you can also define your own registration module for your own kind of content. I will now show how we type check HTML. To do that, we wrote the TY-XML library. TY-XML is using polymorphing variants as phantom types. This makes it possible to check the validity of pages at compile time. This means that it is impossible to write a program that could generate a page that is not valid, that is not following the recommendation of the W3C. This property is almost unique or very rare in the world of web development. This is an example of an error message you get. In this example, I'm creating a paragraph with the P function, and that paragraph contains another paragraph, which is forbidden. This will fail at compile time with this error message. This is a long error message, but it's not difficult to understand. It says, this expression has type P element. This is a paragraph. But I was expecting something of type P content element. And then it explains that P can contain only A, ABBR, audio, etc., 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 but not P. From experience, it's very convenient. It saves a lot of time because you don't need to worry anymore about writing valid HTML and validating your pages afterwards. Let's now see how we generate a link. With Eliom, you don't write the URL yourself. The A function that will generate a link and anchor takes the service as first parameter, then the text of the link as a list of elements, and as a third parameter, the get parameter you want to give to the service in the URL. In this example, this is a list of key value pairs because my service is expecting any get parameter. With this, it's impossible to have broken links because URLs are computed automatically by Eliom. And if you decide to move your service to another URL, all the links will automatically be updated and remain correct. It's also possible to type check service parameters. Instead of saying that my service can take any parameter, I can, for example, specify like this, that it takes an integer named here and a string called name. We have many combinators like this for describing the names and types of parameters. In this example, the third parameter of the A function is not a list of key value pairs anymore. It's just a pair, integer string. The type of the third parameter of the A function depends on the value of the first one. There is some generalized algebraic data types hidden here to make this possible. We have the same kind of typing for forms. We check that the types of the fields in the form match the type of parameter expected by the service. I decided not to show the details of this today because this is not very useful when you write a client-server web app. You will generally prefer calling a client-side function rather than submitting the form the traditional way. But if you want to program a traditional website with Eliom, you will benefit from this feature, and it's very convenient. Let's now have a look at Eliom's session model. This is the part I'm very proud of. I remember I invented this with Raphael Proust many years ago. Sessions are a traditional mechanism that allows you to keep a server-side state for each browser. Browsers are identified by a session identifier recorded in a cookie and sent by the browser with every request. In other frameworks, session data is usually saved in string-to-string key value stores. With Eliom, it's much easier than that and much more powerful. We record session data in what we call Eliom references. Eliom references are very similar to OCaml references, but the value will depend on the session. Every browser can have its own value. In that example, I'm defining a reference called R by calling the function Eliom reference eref, and I can access the value of this reference for the current session using the function Eliom reference dot get. We also speak about scoped references because we extended the notion of session to several scopes. The default scope is the browser, which means that the server-side value will be associated with a particular browser, a cookie. But why not be able to have a server-side state for a particular tab of a browser? Or have a local storage for one request. We also have larger scopes. We can group together all the sessions for one user. Let's say you want to share the same shopping basket on a user's mobile phone and his laptop. That's a very simple way to store user data. We also have scope site, which means one subsite of your server, or global for the whole server. Global is equivalent to usual OCaml references, but with a difference, which is that all these references for all these scopes can be made persistent by adding an optional parameter. Persistent reference will survive after restarting the web server. So you can see that this is both very simple to use and very powerful. And what is interesting is that you almost never use the usual browser session scope. It's much more interesting to use session groups for users. Request scope is also very convenient to store temporary data while generating the page. This was for sessions. Now, I've already shown how to define a service. We've actually completely reinvented the notion of service, raising it to another order of magnitude in terms of expressiveness. First, the service I've shown before are associated to a path in the URL and possibly some parameters. It's also possible to identify the service using a name given as a parameter, regardless of the path. This is useful. For example, if you want the same feature to be available on all your pages. For example, if you want login box on each page, you can use a post service identified by a name that will perform the action of connecting the users. And if you look at the interface of the service creation and registration functions, you will see that they have optional parameters that you can use to protect against some security issues like cross-site request forgeries. And one of the most advanced features we have is the dynamic creation of services. It means that you will be able to dynamically create new services customized for one user or what a user is currently doing. As for sessions, you can restrict the scope of this service to one tab, one browser, or you scope user group of sessions. You can set a timeout to these services or impose a maximum number of uses. Dynamic creation of services is equivalent to what is called continuation-based web programming. This is a programming technique invented about 20 years ago by several people like Christian Keinec or Jean-Vincent Lodo. Continuation-based web programming is implemented in very few web frameworks, mainly because it requires a functional language. But it is the simplest way to solve what is called the back button problem. Continuation-based web programming makes it possible to take very precise account of the specificities of traditional web interaction with the ability to go back in the past of the interaction with the user by pressing the back button or by duplicating the tab. A typical example is booking a train ticket using a several-step form. After submitting each form, you can create new dynamic services that will record the state of previous interaction with the user, the form data, previous form data. They will record that in their closures. I will not insist a lot on this because, once again, this is something useful mostly for website programming. And I'd like to move on to the second part about application development. But this shows that even if you don't plan to write a client-server web application, Eliom is probably the best choice for traditional server-side websites. As I've said before, Eliom makes it possible to keep the advantages of both traditional web interaction and application through its unique programming model based on multi-tier programming. Let's now start the second part of my talk about multi-tier programming with Eliom. The main difference between a website and an application is that in an application, a lot of things are running in the browser. We've made several attempts to run OCaml programs in the browser, and we ended up writing a compiler from OCaml to JavaScript, JS of OCaml. More precisely, JS of OCaml is a compiler from OCaml bytecode to JavaScript, which makes it possible to use it even without recompiling your libraries. It produces a very optimized JavaScript code and is compatible with the most recent versions of OCaml and most recent features like effects. JS of OCaml comes with a standard library for interacting with the browser. Now, WASM of OCaml. WASM of OCaml is a replacement for JS of OCaml, which produces WebAssembly. It can be used as a replacement for JS of OCaml with almost no change in the code, even with access to the DOM using the very recent releases of web browsers. Now, if you write a client-side program with JS of OCaml and XML and Eliom, you will be able to write, for example, your event handler directly as OCaml functions. For example, the onClick attribute takes an OCaml function as parameter. What about doing the same when you generate your page on the server? Eliom makes this possible by using this PPX syntax, squared bracket %client, to include client-side code in your server-side generated pages. More generally, you can mix server-side and client-side code in your Eliom programs by using this syntax. Let %server defines the values you want to be included in your server-side program. Let %client for the values you want to include in your client-side program, and let %shared if you want to include them in both server and client programs. Eliom comes with a Dune-based build system that will use a first PPX extension to extract the server and shared part and build the server-side program. Then a second PPX will extract the client and shared parts and build a client-side program with JS of OCaml. There is also a type checking phase to ensure that both parts are compatible. This multi-tier programming model greatly simplifies the communication between server and client. For example, the client-side program can reference server-side values with this tilde% syntax. These server-side values will automatically be included in the client-side program if there are global value, or they will be sent together with the page by Eliom if such syntax is encountered while generated the page on the server. it is also possible to call a server-side function from a client section. To do that, you just need to declare the server function with the let %RPC syntax, and this will automatically make this function callable from the client. This is actually syntactic sugar for creating an Eliom service, taking an OCaml value as parameter and returning an OCaml value. Remember that with Eliom, communication is always explicit. Tilde % will never perform a call to the server. The programmer decides precisely where he wants the code to be executed by annotating the program, and remote calls are done with this let %RPC construct only. Now, this is a typical example of code you will write every day if you program a web application with Eliom. Take time to understand this example. This is very similar to traditional server-side page generation with the inclusion of client-side code. Here, my function defines a div element, which is returned at the end, or button, and binds some client-side behavior on it. The client-side code refers to the element and some string using the tilde % syntax. And you can see here an example of how easy it is to handle browser events with JS of OCaml and LWT using this LWT.js event module. Function LWT.js events.clicks takes as first parameter the element you want to listen on and calls the function given as the second argument for each click on this element. If you want to be able to build your element from both client and server side, you just need to declare it in a shared section instead of a server section. And if everything is registered in shared section, you will be able to register your service also in a shared section, so that the page can be generated from the client. This is an example of client-server service registration. If the service is registered on both sides, or in the shared section, the server-side version will be used for the first call, or for indexing by search engines, for example. And the client-side version will be used for subsequent calls or on the mobile app to avoid delays when changing page. And this is done automatically using the usual A function for creating Linux that we call the client-side service instead of doing a call to the server. The last part of my talk will show how to write real-world application with Ocsigen. For this, you will need higher level libraries, like, for example, a widget library. Ocsigen provides its own widget library that can be used for client-side programming, but also fully compatible with the client-server programming model, which means that you will be able to build your page elements either from the server or the client. We have, for example, date or time picker, a burger menu, and a carousel that can be used for implementing tabs. For example, let's go to mon club près de chez moi.com, which is another web application written with Eliom. It has a burger menu here. And if I reduce the size of the page, you will see the mobile version. All widgets are usable with your finger on touch screens. For example, here we have what we call a tongue that I can move with my finger. If we go back to Bsport, you can see an example of a carousel with tabs. I'm using my finger to switch from one tab to another here. Ocsigen Start is a higher level library for web and mobile applications. It implements features like user management, creating an account, recovering passwords, etc. It also comes with an application template that is ready to use. Use it as a basis for your application. This application template has many code examples you can use to learn programming with Eliom. On Ocsigen.org, you can find an online demo of this template here, which is running online, at least most of the time. So this is exactly the application you will get if you compile the default template. And if you open the menu, you will see a lot of examples. This is, for example, another version of the carousel. And yet another one. You will also find an example of server-to-client notification, which is another very important feature of Eliom I did not show today, server-to-client communication. Ocsigen Starts also provides all the features you need to turn your web application into a mobile app. Eliom mobile apps use the exact same code as the web application. They run in a web view, embedded in a native iOS or Android application that can be distributed on Apple's App Store or on Google Play Store. To access some of the phone features, you can use Cordova or Capacitor, which provide a JavaScript interface for many native mobile APIs. We have bindings for many Cordova modules. This way of programming mobile apps works perfectly well. That's how Bsport is implemented. Choosing this programming technique for your mobile application will save you a huge amount of time because you will get both of your mobile application for free. So if you want to try application development with Eliom, I really recommend starting by installing Ocsigen Start and using the default template. Even if you don't plan to use it afterwards, you will be able to analyze the code example and try yourself. Take time to read the one-page manual on Ocsigen.org. Be careful, the documentation is huge. Don't get lost. The one-page manual is enough to start. Stay focused. Do not read anything else first. Conclusion. As you can see, Ocsigen is a very complete framework. It offers a very large set of features. All these features come from real world use cases. We receive inputs from users, and from the beginning, we have implemented many applications ourselves. We've spent 7 years with a team of a dozen developers implementing Bsport, a full-feature Facebook-like social framework, social network. And this experience enabled us to meet a wide range of the needs of developers of this kind of application, related to database, scalability, code organization, interoperability with external libraries or online services, ergonomics, etc. We still have lots of ideas to make the development even faster, even more reliable, and simplify the work of developers. Without Ocsigen, it would have been impossible to write Bsport with such a small team and such limited resources. The programming model we invented greatly simplifies the team organization. The usual way programming this kind of application is something like this. You need 4 teams. One for implementing the backend, one for the web frontend, one for the iOS application, and one for the Android app. And you need to make them communicate with each other. You need to make them agree on APIs and agree again every time one of them wants to change something in the API. You have 3 times more bugs, and even more, because you are not using OCaml probably. 3 times more testing, more bugs report, etc. With Ocsigen, you have something like this. One developer is responsible for one feature from the beginning to the end, and from the database to the CSS. And one thing that comes from experience is that developers really enjoy this. It's very rewarding and motivating for developers to be responsible for their own projects, even if it's a small part of a bigger one. So, to summarize this talk, Eliom is the only framework combining the advantages of both web application and web sites. You keep the traditional web interaction, links, forms, server-side generated page, sessions, but with a client-side program that does not restart for each page and can generate pages itself when you click on some link in the page. The main features are extensive use of static type checking, multi-tier programming, and multi-platform for web, Android, and iOS. Eliom and Ocsigen is used in production by large-scale projects, which has made it possible to demonstrate the effectiveness of this programming model. With Eliom, you need a smaller team with more focused developers and less redundancy. You have only one code base to maintain, and type checking helps to have much less bugs and easier refactoring. Very often, people argue that they don't need all these features. But remember that even for basic websites, we provide very nice features that will save you a lot of time. Programming a website with Eliom is very similar to what you would do with any other framework, but with some improvements, like a very simple and powerful session mechanism, or with continuation-based web programming, which makes the implementation of some tricky feature straightforward. You will be able to make it evolve progressively into a more dynamic application by adding client-side features progressively. Of course, you will have to learn some new concepts, reactive programming, handling browser events with scalability, etc. But it will save you a lot of time later. So take time to read the one-page documentation before starting. You might, of course, see some things you don't like. We are very open to suggestions, to comments, to improvements. Ocsigen is an open source project. You can also contribute. Ocsigen has been funded by many institutions like INRIA, CNRS. We are currently looking for new funding to help with the maintenance and evolution of the framework. We are also not very good for communications, so if you can help here, you are very welcome. Ocsigen is one of the main assets of the OCaml language, and we believe that it could help attract many developers to the language. Bisport has shown that using Eliom is a huge competitive advantage for its users. Now, all we have to do is let people know. Thank you.